Hi, everybody. If you'd grab your 6-2 notes, these will follow along with those. We're going to go through adding, subtracting, multiplying, dividing with functions. It's really just like it sounds, but we have to pay attention to the domain. The directions will say always state the domain. So let's start with that because that's the hardest part. Domain really only matters if you have to come up with a restriction. Most domains for most functions are all reals. So let's make a quick list of domain restrictions, or basically things to look out for. Things that make your domain non-exist. 0 in the denominator. That will happen anytime we have a variable in the denominator. Radical in the denominator. That's not allowed. And a negative sign, or a negative number rather, underneath the radical. Also not allowed. So we really just have 3 things to look out for. So if you don't have a fraction or if you don't have a radical, then you just move on and your domain is all reals. I would always start with that. So for this first problem, this has no domain restrictions. But for the radical, it can equal negative underneath the radical, or the radicand cannot be negative. So we'll set this greater than or equal to 0. So we get x is greater than or equal to 1. That's going to be the domain restriction each and every time, unless, of course, it has to become more restrictive. You want to always give the most restrictive. So when we add these, there's not much here to add, so we'll just add this up, x squared plus x plus the radical, and our domain is x is greater than or equal to 1. If you'd like to write this in interval notation, feel free to do that. You don't have to do both. Subtracting would be the same. And of course, our domain is still the same. Now, multiplying, we could argue that we can't really multiply these, but I do think we should probably do some distributive property just to clean it up a little bit. So we're going to have x squared plus 6 times the square root. So I would write this x squared times the square root of x minus 1 plus 6 times the square root of x minus 1, with, of course, our domain being x is greater than or equal to 1. Now, with division, we're going to always create restrictions, always. So be prepared for that. You're not going to have numbers in the bottom of your fractions that you're a little beyond that, so we're not going to see that most likely. So we have x squared plus 6 over the square root of x minus 1. So just set it up and then let's take a look at it. Now think factors, but we can't have a radical in the denominator, so we'll have to fix that by multiplying it by itself. You don't need a conjugate here because the whole thing is under the radical. Now good news is the numerator, we just did it. This is the multiplication problem. So we have x squared times the square root of x minus 1 plus 6 times the square root of x minus 1. The denominator radical sign is gone. But in the denominator, we have created a new restriction. That's the first time we've seen that denominator. So we already have x is greater than or equal to 1, and now we throw in the fact that x minus 1 is not allowed to be 0. So then we get x cannot equal 1. Do not write these as separate. Combine them. Make it look like you actually know what you're doing, because you do. So if it has to be greater than or equal to 1, and, this is an and, it can't equal 1, then all we have is that x is greater than 1. So let's try that again. Again, I'm trying to show you the hardest ones. Don't expect that every single problem has all these issues. It seems like a waste of your time to show you the easy ones. Here we have a fraction. So the fraction's denominator is not allowed to equal 0. So this means that x cannot equal negative 1. And this is none because it's quadratic. Now adding and subtracting fractions is something that we do a lot. We'll do it with all of our trig functions. It doesn't really go away. So I'm going to use this time to kind of help you remember some algebra. First thing we need is a common denominator. Well, we have only one denominator, and that's x plus 1. So the second fraction is going to get multiplied by x plus 1. The first fraction's fine. So I'm just going to rewrite it as one fraction with my common denominator. The x is there. This is a plus, sorry, not a multiply. Now I'm going to have to use FOIL on this, but I'm going to try to be as lazy as possible so it comes up right. So it turns out to be x to the third plus x squared. I'm trying to put it in the right order, minus x minus 1. You have to combine like terms, of course, and we end up with x to the third plus x squared minus 1, because the x's are gone. x plus 1 on the bottom, and our domain is that x cannot equal -1. To subtract, we're going to face much the same process, except we're going to have to distribute a negative sign. So our common denominator is still x plus 1. We still have to multiply this second fraction by x plus 1. But what we have to do now is distribute that negative sign before we combine like terms. So we have x minus, we've already done this, so it's not a lot of thinking. Use what you've done. We're going to distribute that negative sign, but I'm going to rewrite it just right on top of it because I have space. That's a minus, that's a plus. So subtracting is to add the opposite, so that's what I did. I just added the opposite of everything. This is a giant minus sign right here. So we combine like terms, we end up with x to the third minus, it's a negative x to the third, minus x squared plus 2x I feel like it's a plus 1, yeah. And then the denominator is x plus 1, and our domain is x cannot equal -1. Good news is multiplying is going to be a lot easier. So we have x over x plus 1 times x squared minus 1. The thing with multiplying is you want to factor if you can. Factor and cancel, factor and cancel, factor and cancel. So look for it. And so we get here x times x minus 1. You might think, oh, look, no denominator, all reals. Don't fall for that. That's a trick. Now, if you'd like to, you could write this as x squared minus x if you like. That part's up to you. Multiplying it out doesn't change it. It's fine. You still have to include your domain restriction. If x would equal -1, then the whole problem doesn't exist. So you've got to make sure that that's something that you state. So the domain restriction is still there. Now, for a complex fraction, we do a lot with this. Not just the algebra, but really it's with the trig that we do complex fractions. I have a good shortcut, well, a shortcut that I like, and that is to take the two that are farthest apart, multiply them together, that becomes the numerator. Then you take the two that are closest together, multiply those together, and that becomes the denominator. And I'm going to leave my denominator in pieces because I like it like that. We already know that this means x cannot equal -1, but what does this mean? X squared minus 1 cannot equal 0, so x cannot equal positive or -1. So that's the most restrictive, so that's going to be our domain. This is the function simplified, no sense in multiplying it out. Domain, x cannot equal plus or minus 1. When you do a piecewise function, the pieces stay where they are, and you basically do everything twice. So we're going to add P to Q, top to bottom, subtract top and bottom, all of it. So start with your bracket. And when we add x plus 2 plus x plus 3, we get 2x plus 5. That does not change this. X is less than 0. This is the condition under which you're graphing. It's not the condition under which is the domain. When we add this stuff up, P and Q, we get x squared plus x plus 5. And this is if x is greater than or equal to 0. Well, neither one of these things have a fraction or a radical, so your domain is all reals. When you subtract, be careful with your minus sign. X plus 2 minus x plus 3 turns into x plus 2 minus x minus 3. So we end up with -1. If x, you can lose the if you want to, less than 0. And then when we subtract the others, we end up with changing all the signs. X squared minus x, it doesn't combine, so we have x squared minus x minus 3 if x is greater than or equal to 0. And again, our domain is all reals. Now for this, if you don't like my symbol for all reals, you can write all reals. You could write -infinity to infinity. I like the R with the extra line in it. It just seems faster. Now for multiplication, I'm just going to do some quick FOIL. If you like the table You'll have to make your own. But just think about this. You would add to get to the middle and multiply to get to the end. So it's x squared. 2 plus 3 is 5x, and 2 times 3 is 6. I mean, it's pretty fast. Force yourself to rely on your brain. It'll be a lot faster for you. Then we distribute this. The other part would be x to the third plus 3x squared. And this is if x is greater than or equal to 0. And again, our domain, all reals. Here we go with the division. Pretty easy to write this. X plus 2 over x plus 3. This is how it's graphed for numbers that are less than 0. The other one is x squared over x plus 3. And it's graphed for x is greater than or equal to 0. Now we do have a domain restriction. This is not the domain restrictions out here. These are where on the domain does the graph live. So in this case, our domain restriction might be a tiny little hole in the graph, and it's going to be x cannot equal -3. So now what we're going to do is we are going to take p of x and write r of x, which is translated 3 units to the left. Sorry, I'm looking for, we started with x plus 2 and x squared. I just want to make sure I just couldn't think about how it was going to be translated there. I just needed to see it. It wasn't there. So if we think about this, I'm going to start with this line. And right now, we would graph the line less than 0. I'm going to graph the whole line. So we're going to start up 2 and up 1 over 1. So here's my line. Now, I really only care about it from here down, but I'm going to draw the whole line. If we think about moving this 3 units to the left, and if we think about the slope still being 1, it changes our y-intercept. It also changes what we're graphing, or where we're graphing it from. So I only want to graph it from here. I want that point to change. So now I'm graphing it from here. I have to move everything 3 units left. So what happens is, this is now the line. We have a slope of 1 still. Our y-intercept we can see as x plus 5. What really changes is out here. We only graph this if x is less than -3. That's where you're really going to see the left and right. This would be if x is greater than or equal to -3, because the same thing's going to happen with this. So we had a parabola, 0, 0, 1, 1, 2, 4. If we need all that, I don't think we need all of that. And if you think about moving this vertex 3 to the left, we know how to do that. It stays inside the parentheses. And now, of course, we would only graph it from -3 if we wanted our graph to be the same. So we would graph the line from -3, and we'd graph the parabola from -3. So our graph really is the same, just the whole thing moved 3. A little bit tricky. So please make sure you do the assignment. That's on page 88, problems 5 through 9. Check your answers.